you want to learn how an antenna works, stick around. All Electrical is going to give you the know. Next time you pick up your phone, use a radio, watch broadcasted television, or use satellite communications, you'll understand how the information is being transported from one location to another. In transmission, an antenna is supplied with an alternating electric voltage. The antenna then radiates the energy from the voltage as electromagnetic waves. In reception, an antenna intercepts some of the electromagnetic waves, which produces an alternating electric current on the conductor of the antenna. It's through this process that important information is transferred from one location to another. Electrical equipment is used to interpret this electrical information in a way that it ends up being useful to us. There are some important things you need to know to completely understand how an antenna works. Here are the major antenna parameters that affect the way the antenna performs. Bandwidth. Essentially, this means the range of frequencies the antenna can operate at. The supplied alternating voltage on the antenna can oscillate at different frequencies. The range of frequencies the antenna can operate is the bandwidth. Gain. Degree of directivity of the antenna radiation pattern. The higher the gain, the more directive the antenna is. Gain can be compared to light. A light bulb in a room radiates light isotropically, meaning it radiates in all directions. A laser pointer radiates its light in a certain direction. An antenna with a high gain is like the laser pointer in that it radiates its energy in a certain direction. Antenna factor. Ratio of the electric field strength to the voltage induced across the antenna terminals. Antenna factor is usually discussed with receiving antennas. It essentially represents how well an antenna can intercept electromagnetic waves. Impedance. The resistance and reactance seen at the antenna's input terminal. An ideal antenna's impedance is matched to the feed line. The impedance of the antenna is important to know. The reason it's important to match an antenna's impedance to the power feed line is to make the antenna efficient. When you're well matched, you get the best result of radiated power, which brings us to the next important antenna parameter. Efficiency. The ratio of power actually radiated to the power provided to the antenna terminals. The reason this parameter is important is self-explanatory. Would you really want an antenna that is non-efficient? Polarization. The orientation of the electric field with respect to the Earth's surface. When an antenna radiates electromagnetic waves, it uses the propagation of the electric field. The polarization of an antenna depends on the way the electric field is oriented. You'll hear people call antennas vertically, horizontally, circular, polarized. Remember, it's just the way the electric field is oriented. Radiation pattern. Antenna's field strength of electromagnetic waves emitted at different angles. Once again, this important parameter can be compared to a light bulb. The radiation pattern of a light bulb can be directional, which makes the measurement of lumens at different angles drastically different. How strong is the light radiated at a certain angle? How strong is the electromagnetic waves at a certain angle of an antenna? This is radiation pattern. There you have it. You should sufficiently be able to explain to someone how an antenna works. Go find your friend and explain it to them, or just share this video with them. Thanks for watching All Electrical.